Welcome everybody. This is part 3 of my lecture video on section P.1. So if you haven't seen parts 1 or 2, please go and watch them now. In this video, we're going to be discussing number lines and interval notation. Let's get started. A number line is a tool that we use to help us visualize how big or small numbers are. And here I've got an example of that. In this example, we are being asked to graph -2 and 3 on a number line. Typically, we like to have 0 included on our number line. And to the right of 0 are all of our positive numbers, and the further to the right you move on the number line, the more positive they become. And conversely, on the left side are all of our negative numbers. And the more you move to the left on the number line, the more negative that number becomes. So if I wanted to plot -2 on a number line, I would start from 0. Let me do sort of a little dotted circle here, right? I would start there and move 1, 2 spaces to the left and plot my point. Similarly, if I wanted to plot 3, I would start from 0, and then I would move 1, 2, 3 points to the right, and plot my point there. If you recall how to graph on a Cartesian coordinate system, right, in the XY plane, it's basically the same process as that. Now, we often use interval notation to succinctly write sets of numbers, or intervals. And perhaps you have seen this before. In interval notation, we use parentheses and square brackets. And these symbols actually mean different things this time. The parentheses denote exclusion, whereas the brackets denote inclusion. Let's take a look at a couple of examples so we can see what I mean by that. In this next example, I would like you to write each of the following in interval notation. Let's start with part A. -3 is less than or equal to x is less than or equal to 7. So notice these are all of the numbers between -3 and 7. And because I have the or equal to parts, -3 and +7 are both values of x that fit in this inequality, right? The number -3 is greater than or equal to -3, and the number 7 is less than or equal to 7. So I should include both of those numbers in my interval. That means I use square brackets around them, right? So this -3, 7 in brackets is a more succinct way of writing the inequality given above. Same thing for part B. Here I'm looking for all numbers between -pi and pi. But notice this time I don't have the or equal to part. So I'm still looking for -pi to pi. Still looking for that one. But this time, -pi is not greater than -pi, and +pi is not less than pi. So I don't want those numbers to be included in my interval. To denote this, I use parentheses, not brackets. This distinction is going to be incredibly important, so I would like you to get some practice doing some more. I'd encourage you to pause the video here, and then see if you can figure out how to write these next two, or let's just say next one, on your own. See if you can write part C. Notice that this time I have an equal to on the left inequality, but not on the right inequality. That means -1/2, the number on the left side of the interval, should be included, but not the number on the right side of the interval. Even though it looks funky, I do need to write that down so that the reader, aka me when I'm grading your papers, knows which numbers are included. So I use a square bracket on the -1/2, but a parenthesis on the 4. Now, We also may see things like D, where I don't have a number or an inequality on both sides of my variable. Here in part D, I've just got x is greater than 4. But I can still denote this in interval notation. Right? These are all of the numbers from 4 onward until it gets incomprehensibly large, right? I just keep counting to the right. The way that I denote this to the reader is by writing 4 comma infinity. Now you'll notice that 4 is not included in this interval because 4 is not greater than 4. So I'm going to use a parenthesis around the 4. As a convention, we always write parentheses around our infinities. The reason for this, and this is kind of a tricky topic, so I won't go too in-depth here, but if you have more questions, please come ask me in office hours or shoot me an email about it. Infinity is not a number. It's just an idea. So when I write 4 comma infinity, I'm telling the reader it's the numbers 4, 5, 6, 7, so on and so forth forever and ever. Right? It wouldn't make sense to include a number that's not a number in the interval. So we use parentheses. Takeaway from that is always use parentheses with infinity. I always want to use parentheses with plus or minus infinity. That said, I've got one last example for you. See if you can pause the video here and try it on your own. This one was kind of a trick question because all of the numbers work. It doesn't matter how negative the number is or how positive the number is. All of them are included in the real numbers. So I write that interval as minus infinity all the way up to infinity, right? Everything works. And on both sides, because I have an infinity on both sides, I always use parentheses. Next, we're going to talk about graphing intervals on a number line. We've already seen how to graph points, and now we understand what intervals are. Let's marry those two ideas by graphing each of the following on a number line. Here, I want to graph -1 to 1 on a number line. And if you're practicing your interval notation, you should be able to find that that's this interval. -1 to 1, including both. On my number line, I want to plot both endpoints of my interval, being -1 and 1. In this case, I'm including both of them. So I'm going to use a filled-in circle to denote that inclusion. And then I shade the region in between them to show the reader that everything between those 2 points is actually in the interval. Similarly, let's see what happens. Oh, let me scroll just a little bit more. Similarly, let's see what happens when we don't have inclusion. Here we should know that this is the interval from 0 to 2, but neither 0 nor 2 are in the interval. The way we denote this to the reader is with an open circle. An open circle on both of our endpoints. But everything in between those numbers are still in the region, so we need to shade them. Alternatively, you may see these kinds of inclusion-exclusion things denoted with their parentheses or bracket counterparts on the number line. So in example A, an alternative way to answer this would be to use parentheses. To use brackets. And in part B, to use parentheses. You may use whichever set of notation you prefer. I can read them both. Go ahead and pause the video here now to see if you can try example C on your own. Hopefully we were able to arrive at this answer. Alternatively, you may have used a bracket on the -4 and a parenthesis on the 1. You'll also notice that my number line is missing a few numbers. I've only got the even ones here. That's because it made it more convenient for me to be able to fit more information in the same amount of space. You are more than welcome to use whatever kind of spacing convention you would like to, just as long as you label it for me. So here, I've got a closed dot on -4 to show that inclusion from the less than or equal to sign here, or excuse me, greater than or equal to sign here. And I've got an open circle to show the exclusion on this less than sign here. Last one. See if you can try x is less than or equal to -1 on your own. Welcome back. This one's a bit of a trick question because I don't actually have a left endpoint. If I were to write this in interval notation, I would write -infinity up to -1, and -1 should be included. So surely we can all agree -1 should be on our plot. But what about the left side? Well, they're all there. So I write my closed circle on -1 to show my inclusion, and then I shade everything to the left. Our next topic is going to be how these ideas of number lines and intervals relate to the sets we were talking about in the previous video. But in order to see that, I've got a couple more vocab words for you. The first one being union. The union of two sets is the set of everything in A or in B, if A and B are those sets. And we write sort of this big capital U between them. So that A, U, B is really A union B. And I think that these are easiest to understand by looking at a picture. So let's graph some things. Like this one. The interval from 1 to 3, including only 1, union the interval from 4 to 5, including both. The union of these two intervals is all of the numbers from both intervals, right? It's any number that's in one, the other, or both. So, in order to graph it, in order to graph it, I will need to graph both intervals. So here, I've got the interval from 1 to 3, and I'm going to include 1, but not 3. Closed circle on 1, open circle on 3. I've also got the interval from 4 to 5, including both. Now I just need to shade. So I shade between 1 and 3, and I shade between 4 and 5. Let's try another one. Why don't you pause the video here to see if you can sketch the graph of -2 to -1, including -2 but not -1, unioned with the open interval from -1 to 0. That means including neither. This is the answer that I got for this problem. You'll notice that I have a closed circle on -2 and an open circle on -1. Then I shade the numbers between them. Similarly, I get another open circle on -1 and then another open circle on 0, and I shade the number between them. Notice that -1 is not a part of either interval, so it should be left out of our shaded region. Similarly to the union, we can also talk about the intersection of two sets, A and B. The intersection is the set of all things that they share, and this one can be a little trickier at first. To write the intersection, we use the union symbol, but upside down. Again, I think that these are kind of easiest to see with a picture. So let's look at how we would graph the intersection between the closed interval from 2 to 6. Again, that word closed means it has both its endpoints. And the closed interval from 4 to 8. The intersection, remember, is the set of all things they share. So sometimes it's helpful to sketch the graph of both of them, right? So I've got a 2, oops, and I'll do this in gray here since this is not going to be my final answer. I've got 2 to 6. Here's what that looks like. And I've got 4 to 8. And here's what that looks like. So their intersection is going to be everywhere it overlaps. Notice that's going to be the section from 4 to 6. And I'm including both of the endpoints there because 4 belongs to both of these intervals and 6 belongs to both of these intervals. All together now, I'm going to have a closed point at 4, a closed point at 6, and then I'm going to shade the region between them. Why don't you pause the video here to see if you can try this problem out? Ultimately, we get almost the same answers in part A. We get the open interval from 4 to 6 instead of closed. Here, the word open means it has neither of its endpoints. When we sketch both of these individually, like you can see in gray, 4 and 5 both almost look like they're in both sets. The problem being that 4 is in the set on the left, but not in the set on the right. And 5 is in the set on the right, but not in the set on the left. So unfortunately, we can't include either of them in the intersection, but all the numbers between those certainly are. So we shade everything in between. That's going to wrap it up for this video and for this section. Next, you'll want to move over to section P.2, which is on exponents and scientific notation. Catch y'all in the next one.